All right, guys, I want to give you a quick video on graphing rational functions. Today, we're going to talk about the different types of intercepts and asymptotes we can get when we graph these rational functions. So first off, let's maybe think of a rational function like this, x plus 1 over x squared minus 4. The first thing we're going to check is the x-intercepts. Okay, x-intercepts are the zeros of the numerator at the top. So in our case, the example that I gave, x plus 1, if we set that equal to 0, of course, x has to equal -1. Okay, so that is where, on our graph, at -1, where it would cross the x-intercept. Okay, the next thing we have to look at is vertical asymptotes. Okay, vertical asymptotes is the zeros of the denominator. And in our denominator, in our example, we have x squared minus 4. So again, if I set that equal to 0, x squared, if I add 4 over, equals positive 4. Take the square root of both sides, x equals plus or minus 2. Both positive and negative 2 there. So at 2 on both, at -2 and +2 on our x-axis, we'd have vertical asymptotes. All right, and we'll check out graphs of these here in a little bit. Next thing we're going to check is the horizontal asymptote. Okay, and we have 3 different cases, and either the degree is going to equal the top and the bottom, like in this case, they're both x squareds. All right, if they equal, then what's going to happen is you're going to use the coefficient of the top over the coefficient of the bottom. Coefficient of the top over the coefficient of the bottom. So, or the leading coefficient, I should say. So here we have 2 as our leading coefficient. Down here we have 1. So 2 over 1, or just 2, is going to be our horizontal asymptote. So and this is where y equals 2, because horizontal, if you think of that, that's the line y equals something. So it would be y equals 2 in this case. Case 2 is when a degree of the numerator is less than the degree of the denominator, right? Or you can think of it, the smaller one is on top. In this case, remember, this is like x to the first over x squared. What this is going to be is just y equals 0. All right, so when the smaller degree is on top, y is going to equal 0 for our horizontal asymptote. In the last case, case 3, is when the numerator is greater than the denominator. So for example, I put a case like this. X to the third is our largest degree on the numerator, and again down below we have x to the first. Okay, what happens here is there's no horizontal asymptote. There isn't going to be one, but there might be a slant asymptote. And remember, to check for those, we're just going to divide, and we can use synthetic division in this case because remember, we could just set this equal to 0. X would be 4, so we're going to divide by 4. And let's see, we have a 3, 2, 1. We're missing the 0. I could say plus 0x to the 0 over here. And that would be filling in with 1, -1, 2, and 0. And then if you do synthetic division, it is a little bit tricky because we have to bring down our 1. Let's say it's going to be 4, 3, 12, 14, let's see, 40, 16, is that 56, I think, 56. So it's tricky because this is going to be x squared plus 3x plus 14, but you don't use the remainder. Okay, you do not use the remainder. Remember, these are asymptotes, and so eventually they're going to go to 0. Don't want to really mathematically get into it, but you would not use the remainder. This right here would be the slant asymptote, if there would be one. Okay. All right, so let's try a couple of examples. That over there. The first one, we have 2x squared over x squared minus 9. So this is an example where our x-intercepts, we have to set the top equal to 0. All right, so 2x squared, let's see, 2x squared equals 0. So if I divide by 2 on both sides, I get x squared equals 0. Take the square root of both sides, x equals 0. All right, so our x-intercept is going to be 0, which means that x equals 0 is going to cross my x-intercept. This is my x. All right. And I think I can bring this over. Let's see. We'll do that here in a second. Vertical asymptotes. Vertical asymptote for this one, we're going to set the bottom equal to 0. And when I do that, we're going to have x squared minus 9 equals 0. Add 9 to both sides. X squared equals 9. Square root of both. X equals plus or minus 3. Okay, plus or minus 3. So at 3, let's see, 1, 2, 3, and at negative 3. Okay, since these are asymptotes, what I'm going to do for this one, I'm going to bring these over. Now I think it'll work here and here. Trying to kind of bound our regions. And then the next one we're going to use is the horizontal asymptote. Remember, horizontal asymptote, we had those 3 different cases. This is going to be one where the degrees are the same on the top and the bottom. And when they're the same on the top and the bottom, we use the leading coefficients. In this case, 2, and in this case, it's a 1. So 2 over 1 is just 2. 2 over 1 equals 2 for our horizontal asymptote. So if I bring this down to 2, like this, our region is going to be kind of bounded like so. Okay. All right. Then to graph it, you can do a couple things. First off, let's just plug in maybe a number close to 0 and see what happens. If I plug in 1, to this, I'll switch colors. That's going to be 2 times 1 squared over 1 squared minus 9. 1 squared is just 1. 1 times 2 is 2. And on the bottom, again, 1 squared is 1. 1 minus 9 is negative 8. So this would be negative 1/4. Negative 1/4. So at 1 and at negative 1, because if I square, it's going to be the same thing. It's going to be negative 1/4, which means it's going to be here and here. And so what this tells me is this is going to be bounded kind of like that. All right, kind of like that. I don't really have to go much farther, putting in like 2 and negative 2 into the equation to figure that out, because in that region, it has to be bounded by those asymptotes. Okay. Similarly, in these regions, to figure out what happens there, we know it's not going to cross our x-axis, right? Because our x-intercepts were only 0 right there. They're only 0. So what we can do is maybe again plug in something and see what happens when I do that. Let's plug in maybe 4, right? Plug in 4. So it's going to be 2 times 4 squared over 4 squared minus 9. 4 squared is 16. 16 times 2 is 32. On the bottom, 16 minus 9 is 7. So 32 divided by 7 is positive. 32 divided by 8 is 4. So this would be, what, a little bit more than 4? So 4 would be about there, and about there. Okay, and we can assume that's going to be going down like this. Sorry about that. I had someone come to my door. And then the other side would look very similar, where again we come close to that asymptote through our point we found, and then again back close to the other asymptote. Okay, last thing we want to do for this is write the domain. The domain is going to be broken up into different parts, in this case 3 different parts, where the farthest left part is going to go from negative infinity to negative 3. Write that a little better. Negative infinity to negative 3. And we bound those with parentheses for the infinity. The negative 3 is also going to get 1 because this is an asymptote. It gets close but never quite there. All right, then we're going to use the sign, which is union. It looks like a big U. With our next section, and that goes from negative 3 to positive 3, again using just parentheses, because it gets close but never quite touches, and then union with +3 to positive infinity. Okay, and that's the domain of this graph. Let's see if we can do the next one just a bit quicker. This one, -2 over x squared plus 2. Okay, so a couple things. First off, our x-intercept is -2 equals the top, or equals 0, which is false, right? That's not true. -2 does not equal 0. So there's going to be no x-intercept in this one. Our vertical asymptote, this is where we set the bottom equal to 0. So that's going to be x squared. If I subtract the 2 to the other side, is -2. Take the square roots. Again, you can't take the square root of a negative, and so again, this is also going to be none. There's not going to be a vertical asymptote in this one. Okay, and then the last thing I have to check is the horizontal asymptote. Remember, this is our third case, I think, where the bottom, or maybe it's the second case, where the bottom's larger, or the top you can think of as a smaller degree. And so when that happens, y is going to equal 0. All right, so we are going to have a horizontal asymptote at 0. I bring that down like this. Okay. All right, so again, let's see if we can maybe plug in a couple things, see what happens. Let's plug in 0, see what happens at 0. That should be my pen here. -2 over 0 squared plus 2. That's going to be -2 over 2, which is just -1. So at 0, we're going to be down at -1 on our graph. And then we have to fill in, maybe let's find 1, and then that should give us a good indication of what's going to happen in the rest of it. So at 1, this is -2 over 1 squared plus 2. -2 over 1 squared is 1, 1 plus 2 is 3, so -2/3. So it is going to be negative, but not quite -1 like our last one was. That's -2/3. Okay, and since it is bounded here at 0, I can again assume that this graph is going to start close to 0. It's going to kind of dip right here, and it's going to go back close to 0 and never quite touch or cross over. All right, so that is the graph of this function, and this one has an easy domain since it's all the real numbers are just -infinity to positive infinity, both with parentheses. All right, next one, g of x equals x squared minus 4x plus 4 over x minus 1. This one looks a little bit interesting. So our x-intercepts, if we look at the top, we can factor that. This is going to factor to be x minus 2 and x minus 2. Okay, and so if I set those equal to 0, x equals +2. So x equals +2 is our x-intercept. We're going to touch right there, across I should say. Our vertical asymptotes, if we set the bottom, if we set the bottom equal to 0, x minus 1 equals 0. Well, x would have to be +1. If you add 1 to both sides, x equals +1. So we can have a vertical asymptote right here at +1. Okay, and then our horizontal asymptote, remember this is the case where our top is larger, has a larger degree, x squared over x to the first is larger. So this one actually is not going to have any, we can say none, but what it is going to have is a slant asymptote. It says when there is no horizontal asymptote, we have to check for a slant asymptote. Again, the way we do that is we're going to look at our bottom, which is x minus 1, so we're going to use +1 and use a little synthetic division to divide by our top. Our top is 1, -4, 4. 1, -4, 4. Extend this so we can see it. Bring down the 1. 1 times 1 is 1. -4 plus 1 is -3. -3 times 1 is -3. 4 minus 3 is 1. All right, again, when we check for a slant asymptote, the remainder, right, this is our remainder, our linear our constant in our linear function. The remainder, we don't use that. All right, we just use the rest. So this ends up being x minus 3, or you could think of this as y equals x minus 3. And that's going to be our slant asymptote. So y equals x minus 3 is the line. We start down here at negative 3, and it's y equals x minus 3, so we're going to go up 1 over 1, 1 over 1 as many times as we can here. And it ends up being this line. I'll just use the dotted line. In fact, maybe I'll use a different color. Like this is going to be our slant asymptote. Like so. Okay, so what is this doing? Well, again, we can kind of predict a little bit what this graph is going to do, because it's going to cross here. We know it's going to cross here at this 2. Okay, at x equals 2. So it's probably going to start close to this asymptote, come down here, touch at the 2, and then start going back towards this one. Okay, and this one is going to do very similar thing. It's going to start down there, get close to the kind of vertex of that, if you will. Oops, and then get again back close to our other asymptote. Looks something like that. If you really want to know, you can graph this on Desmos, but our goal is to find the x-intercepts, the vertical asymptotes, the horizontal asymptotes, and then give a general sort of graph of this. Or in your homework, you're going to see where you're given a graph, and you have to decide which graph goes with which function. Okay, so that is what this one is going to look like. And then lastly, the domain of this is going to be from negative infinity. And remember, it breaks there at our vertical asymptote of 1, okay, where those both get parentheses, union with 1 to positive infinity. Okay, that's the domain of that one. All right, let's try this one now. This is negative 3x squared plus 2 over x minus 1. X-intercepts set negative 3x squared plus 2 equal to 0. Subtract 2 and divide by negative 3 should give us, I think that's x squared, should give us x squared equals 2/3. Again, subtract 2, divide by negative, we'll turn that positive. We've got to take the square root of both, giving us x equals plus or minus the square root of 2/3. I think we just have to leave it like that. Square root of 2/3. And that's for our x-intercepts. So 2/3, square root of 2/3 is going to be greater than 1, but not quite 1. Or greater than 0, but not quite 1, I should say. So here and here. All right, we also have vertical asymptotes. That's going to set the bottom equal to 0. X minus 1 equal to 0 is going to be x equals positive 1. So that's a vertical asymptote at 1. Like that. Okay, and then a horizontal asymptotes. This is where the top is greater than our bottom. So again, this one is going to be none. That's our third case, where our degree on top is larger than our degree on the bottom. So this is going to be no vertical asymptote. And so what we have to do then, again, is check for, oops, it's not wanting to scroll on me here. We have to check for our slant asymptote. There we go. Our slant asymptote, the bottom is x minus 1, so we can use positive 1. And do our division, which again, we'll have negative 3, 0, 2. I think that's what they were. Negative 3, 0, 2, yep, because it's missing the x term. Bring down a negative 3. Negative 3 times 1 is negative 3. 0 minus 3 is also negative 3. Negative 3 and negative 1. And you don't use the remainder, just use your x and your constant term. This is negative 3x minus 3. Or y equals that. And again, the equation y equals negative 3x minus 3. Start down here at negative 3, go down 1, 2, 3 over 1. 1, 2, 3 over 1 more. Do that a few times, and then also up here, you could go up 1, 2, 3 over 1, 3 over 1, and there. Okay, so we get that kind of a line going. Maybe I can use my red one to show this. Okay, now again, the two dots that I had earlier at what was that? The square root of plus or minus 2/3 here and here. Again, those are just approximate, but what that tells us, since those are kind of in this region bounded by our two asymptotes, slant and our vertical, shows me that this is going to look something like this. Again, kind of that V shape. Oops, let me retry that one. And these don't have to be perfect, just kind of get the idea going through that like this. And then the main thing we want is the domain, and so this is going to be from negative infinity and then stopping again at 1, union with 1 to positive infinity. Okay. All right, so I think that is all we have for today. We're going to now do our 5.3 worksheets, which I'll have for you in class or on Google Classroom.